Next topic of discussion in the course is going to be gears. Gears, next to springs, gear plays a very important role in mechanical systems. Today, in the era of electronics, of course, gear is taking a back step in all the domestic appliances. It is all getting replaced by micro electromechanical systems, but gear still plays an important role when we talk about high torque, high force transmission. Wherever you wanted to have a positive drive, whatever I give, it has to be transferred. So, the other way around is gears are like multiplying factors or dividing factors which you can get it done in a mechanical system. Say for example, in a calculator 2 into 3 6, you multiply. Hydraulic system also you can multiply and reduce. Gears are also in the same way. You can amplify the speed, amplify the torque and amplify the force whatever it can lift. So, gears play a very important role. When I say gears, there are different types of gears, spur gear, helical gear, right? You have herringbone gear, so many different types of gear, bevel gear, worm and worm wheel. So many gears are there which will try to give you a multiple output. So, understanding gear is very important. From the ancient days to the latest, the advanced dates or to the technology days, gear plays a very important role. As I gave you an example of opening a door for a temple, opening a door for a cave, opening a door for a kingdom, gears were also used. Bevel gears were used way back 20,000 years ago. So, gears is very important. Getting into the content, we will try to see what is gear, few of the gear terminologies, conjugate actions in gears, gear classification, gear kinematics, gear train, gear ratio, force on gear teeth, stress analysis in gear, and finally, we will try to have a recap. Introduction to gear. If you look at all the photos here, these are all different types of gears. You can see gears, the gear teeth is along the axis of rotation. It is at an angle inclined to rotation. Here you will see two gears which are trying to mesh. This is an input, this is an output. So, you can try to have multiple factor multiplication or you can try to reduce whatever you want. So, all these things are gears. A gear is a rotating machine element with teeths that mesh with another toothed part to transmit torque. The teeth can be inside, it can happen here or it can be on the periphery. The mating partner should also have gear teeth. Gears are used to change the speed, torque and the direction of the power source. So, here it is almost like that. They work by transmitting rotation motion and force between two or more shafts, which allows for precision control of mechanical systems. In watch, Swiss watch, where the time used to be very minutely controlled, has lot of gears. One of the engineering marv in mechanical engineering domain is watch manufacturing. Very precise watch manufacturing, which has happened 150 years ago. Applications. Gears are integral to many mechanical systems, including automobile, automotive transmission, industrial machinery, clocks, and even small devices like electric drills. This is what is an example I was trying to talk about, internal gear. So, inside you have a teeth which is made, and then you have a pinion which goes around it. So, this will try to rotate around the teeth, meshing the teeth, it will go around. Okay. So, this is worm and worm gear. So, wherein which you have a worm and this is the worm wheel. So, here you will have teeth. This will have a similar profile wherein which this and this tries to mate with each other. You can have external gears, right. You can have rack and pinion. So, wherein which this is a rack which is for straight line motion, pinion is for rotatory motion. You can have ball and ratchet mechanism. We saw it in the previous lectures. Screw gears are also there, right. Almost all different types of gears are shown here in this figure. Their ability to efficiently transmit power and adjust the mechanical advantage makes them essential in a wide range of applications. These gear material can be made out of metal or polymer. All the toys, they use plastic gears because the loads are not very heavy. In automobile industry or automotive industry or in machine tool, we always use metal gears. Again, the material for metal can be mild steel, can be stainless steel, can be copper, can be nickel, can be brass. You can use anything of your choice depending upon your requirements. So, gear classification based on shaft arrangement, based on shaft. What is shaft? This is a shaft, and on a shaft you press fit and keep a gear, or the shaft and gear are integral part of the same part. Both are possible. You can, depending upon the diameter of the gear, so it can be used for multiplication or division. That means to say, for one rotation it can rotate 5 times, or it can rotate 5 times to do one rotation. Both are possible. So, when you have parallel shafts, the gear what we use is spur gear. The most common type of gear with straight teeths that are parallel to the axis of rotation. This is very easy to manufacture, and it also has proper meshing. Thus, gears are used in simple machinery like clocks, conveyors, where the shafts are parallel. Similar to spur gear, we will have helical gear. The only difference between spur and helical is the teeth cut are at an angle. So, what is the difference? Why we have to go for this? Here, when it runs, it is a smoother and a quieter run will be achieved by helical gear, and more contact area is there. So, loads can be heavy as compared to that of the spur gear. Helical gears are used in automotive transmission and other applications requiring high speed and high load capacity. Intersecting shafts, bevel gear. Bevel gear, gear with conical shape that allows them to transmit motion between intersecting shaft, typically at right angles, commonly used in differential drives which allow car vehicles to rotate at differential speeds. Right? Differential will be used in trucks at the rear end, where you will have wheels, the tire is attached to this, and then you have a gear which tries to convey from the engine to the tire. Okay. So, differential drives are possible. You also have something non-intersecting and non-parallel shafts. The first one what we saw was parallel shafts, then we saw is intersecting shafts. The third one is non-intersecting and non-parallel shafts. For example, it is worm gear. This is the worm gear example. So, consists of a worm, a screw-like component meshing with a worm wheel. This is a wheel, this is worm, similar to that of a spur gear. These gears are used in elevators and conveyor systems where high torque and low speeds are needed. High torque and low speeds. For example, you want to make a turntable. Turntable also you can try to make it using worm and worm gear. What is turntable? It will be a table. Okay, let me give you an example. When the engine comes from one direction, the engine direction has to be changed. What we do is, we move the engine into a turntable, we rotate the engine in 180 degrees and then move it back. The place where it happens is called as a turntable. A turntable is always used to rotate using a worm and worm gear. Or you can also try to have a sliding, but worm and worm gear is the one which is exhaustively used. Hypoidal gear. These gears are similar to bevel gear in the top, but with an offset between the axis. So, this axis and this axis, there is an offset, providing a combination of parallel and intersecting shaft advantage. They are used in automobile and for smooth power transmission. If you see, almost all the gears will be used in automobile. Spur gear, helical gear, bevel gear, worm gear and hypoidal gears. Everywhere everything is used. The only difference is what is the direction, what is the power and what is the speed. Depending upon that, it can do. The axis from where the drive is given can be parallel, perpendicular, it can be intersecting, non-intersecting. So, based upon the tooth design classification, straight teeth. Straight teeth are always found in spur gear. Have teeth straight and parallel to gear axis. They are simple and cost effective, but can be noisy under high speed. In order to avoid the noise, we always go for helical gear. The gear teeth are cut at an angle to the gear axis, which allow for more gradual engagement of teeth so that it results in quieter and smoother operations. You have double helical gear or teeth, double helical teeth. Double helical teeth is called as herringbone. Double helical gear features two helical axes. So, you can see 1 and 2. This is 1 and this is 2, right. So, two helical gear joins together with opposite helical angles, which eliminates axial thrust and balances out the force. It eliminates axial thrust and balance out the force. These are used in heavy machinery like turbines and compressor. You can also have something called as curved teeth. The teeth are all curved. So, the example is bevel gear, often have curved teeth to provide smoother engagement and transmission of torque between the intersecting shafts. So, what are the practical applications? Spur gear found in simple mechanical device like clock, washing machine, conveyors. Helical are used in automobile transmission, mixture and heavy machinery requiring smooth and quiet operation. Bevel gear employed in automobile differentials, hand drilling and rotating device requiring change in direction of drive. Worm gear, it is used in tuning instruments, elevators and hoisting equipments due to the ability of high torque and low speed. Ellipsoidal gear seen in differential of rear wheel drive cars, where they provide smoother power transmission between the engine and the wheel. So, this will be rare hypoid gear seen in differential of rear wheel drive cars. There are front wheel drive cars, rear wheel drive cars. In rear wheel drive cars, hypoid gears are used, where they provide smoother power transmission between the engine and the wheels. If you look at it, this is a hand drilling machine, where in which you use a bevel. This is a gear train, where it is used in lathe machine for changing the speeds. It is inside a gear box, helical gear. Inside a watch, spur gear. right. This is worm and this is hypoid. Various examples are given. If you see here, you see the axis, you see the inclined angle of the teeth, it will be more clear. Now, let us understand some of the gear terminologies. In gear, there are several terminologies. So, we will try to cover one after the other. The first one is called as the pitch circle. Pitch circle is the theoretical circle upon which all calculations are usually based on. Its diameter is called as the pitch diameter. So, this if you see here, pitch circle is written, right, pitch circle, you see a dotted line which goes. So, the diameter is the pitch diameter for the pitch circle. This is what it is. Almost you can see for discussion sake, it can be half or slightly above half. The pitch circles of a pair of mating gears are tangent to each other. So, this one and this one are of the mating are tangent to each other. A pinion is the smaller of two mating gears. The larger one is often called as a gear or a bull gear. So, larger gear, smaller gear. The circular pitch P is the distance measured on the pitch circle from the point of one tooth to the corresponding point of the adjacent tooth. Circular pitch. You see here P, circular pitch. So, circular pitch is from this point wherever it is starting to the next point of the ending, right. It is, if you try to take pitch in a sinusoidal wave, this is called as a pitch, right. In a gear, it is also the same, from this extreme end to this extreme end. So, from the end of one teeth to the end of the other teeth. Thus, a pitch circle is equal to the sum of tooth thickness and the width of the space. Module. Module is the ratio of the pitch diameter to the number of teeth. The customary unit of length used is millimeter. The module is the index of a tool size in SI. So, what is module? Module says a ratio of the pitch diameter to the number of teeth. So, ratio pitch diameter P to the number of teeth, let us take it as N, is called as a module. Diametral pitch P is the ratio of the number of teeth on the gear to the pitch diameter. This is the reciprocal of module. Module, inverse of module is diametral pitch P. Since diametral pitch is used only with US units, it is expressed as teeth per inch. So, module 1 by module, inverse of module, diametral pitch. Addendum and dedendum. From the pitch circle diameter to the tip of the gear is called as addendum. From the pitch circle diameter to the root, it is called as dedendum. This is an approximate definition. Let us see. The addendum A is the radial distance between the top land, this is the top land, and the pitch circle. Top land and the pitch circle is addendum. The dedendum is the radial distance between the pitch circle between the land, bottom land, this is called as a bottom, this is called as a top land, this is called as a bottom land. Between the bottom land and the pitch circle is called as dedendum. Whole teeth HT, whole teeth HT, it is the sum of A plus D, it is called as the whole depth, called as a whole depth. Clearance circle is the circle that is tangent to the addendum circle of the mating gear. It is tangent to the addendum circle, tangent. So, suppose if it is going like this, it will go like tangent, right. So, is a circle that is tangent to the addendum circle of the mating gear. The clearance C is the amount by which the dedundum in a given gear exceeds the addendum of the mating gear. Clearance C is very, very important. Clearance, you see here clearance. So, this is the whole depth, right, A plus D. This is the working depth. The difference between the two is called as the clearance C. So, when two gears meet, there has to be a small clearance. Perfect contact means it is going to be very tough, there will be a lot of friction. Backlash is the amount by which the width of the tooth space exceeds the thickness of the engaged gear measured on the pitch circle. So, backlash is also a very, very important phenomena. So, when two teeth meet, there will always be small clearance. This small clearance is called as backlash, because what is the effect of backlash? So, when you rotate it in the forward direction, you might come back to this position at 0 point. But when I reverse do it, when I want to come back, the angle of rotation need not be the same. If it is not the same, then it is called as backlash. As and when the wear and tear happens on the teeth, you will always have backlash more. I repeat, width of the space exceeds the thickness of the engaging gear which enters inside. So, let us see some of the other gear terminologies. So, the formulas whatever we have discussed, P is equal to N by D, P is equal to pi D by N, which is pi M, M is the module which is D by N. Then we have, so this too has to be small p, which p is equal to pi. This is the fourth equation. So, now let us write it down. P is the diametral pitch, or it is teeth per inch. Then N is the number of teeth. D is the pitch diameter. Then we have M, which is the module. The last one is going to be small p, which is the circular pitch. So, these are important formulas which we discussed till now. Formula. Conjugate action in gear. Conjugate action refers to the specific motion relationship between two meshing gears, where the contact between their teeth maintains a constant velocity ratio throughout its rotation. So, this is very, very important. Conjugate action refers to a specific motion relationship, first point, between two meshing gears, with the contact between the teeth maintained a constant velocity ratio throughout the rotation. So, we can see here cam A and a follower B in contact. When the contacting surface are involute profiles, the ensured conjugate action provides a constant angular velocity ratio. This ensures smooth transmission of power and torque with minimal variation in speed, preventing fluctuations that lead to mechanical inefficiency, where the constant velocity ratio is maintained. In conjugate action, the profile of the gear teeth are designed such that the line of action remains constant during the meshing process. The most common tooth profile that ensures the conjugate action is the involute profile, which is widely used in modern gear design. Conjugate action in gear is very important. You will try to get a constant velocity ratio such that there is no velocity fluctuations. So, that leading to force fluctuation. So, the importance is conjugate action is crucial for the efficient and reliable operation in gear systems. It allows for continuous smooth transmission of motion between gears, reducing the risk of noise, vibration and wear. Conjugate action is important. It finds its application in automobile transmission, ensures smooth power transfer between the gears, machine consistent speed in industry machines, watches and clocks. It provides accurate timekeeping by ensuring precise gear movement. We were talking about velocity ratio. So, what is velocity ratio? You are supposed to understand. This falls under the topic of gear kinematics. So, there are two gears. One is called as driven gear. The other one is called as driving gear. Okay. The velocity ratio in gear refers to the ratio of the angular velocity of the driven gear, moved gear, to the angular velocity of the driving gear, moving gear. Driving gear will be attached to a motor or something. It is a key parameter in determining the mechanical advantage and the speed reduction increase provided by the gear system. Velocity ratio is written as angular velocity of driven gear divided by angular velocity of driving gear, or it can be written as number of teeth on driving gear divided by number of teeth in the driven gear. Okay. So, look at it, it is inverse. Velocity ratio, angular velocity of the driven gear divided by the angular velocity of the driving gear. When we talk about velocity ratio, we of the gear in terms of gear teeth, we try to talk about number of teeth on driving gear divided by number of teeth on the driven gear. The velocity ratio helps in understanding the speed and the torque relationship between the gears. A higher velocity ratio indicates that the driven gear will rotate slower, but with more torque. That is what I said, when you use gear, we try to change the speed, we try to change the torque and we try to change the power, right. A higher velocity ratio indicates that the driven gear will rotate slower, but with more torque, while the lower velocity ratio means the driven gear rotates faster with least torque. Please understand the difference. Let us try to solve a simple problem. Consider a simple gear train where the driving gear gear A has 20 teeth and the driven gear B has 40 teeth. The formula is velocity ratio is equal to teeth on gear A divided by teeth on gear B. So, 20 by 40, 1 by 2. This means that for every 2 rotations of gear A, gear B makes 1 revolution. Moving further into gear trains, there are simple gear trains, compound gear trains, riveted gear trains, epicyclic gear trains. So, simple gear trains are consisting of 2 gears commonly used to change the speed or the direction of motion. So, here you should also make a note, it also changes the direction of motion. So, speed or the direction of motion. Compound gear involves multiple gears on the same shaft, allowing for faster speed or torque variation. You can have multiple gears. For example, this is called as compound gears. So, you will have an idler in between, you will have a compound gear, you will have an idler. So, you will have an output, you can have multiple things. So, here simple gear train only 2 gears, here more than 2, involves multiple gears on same shaft, allowing a greater speed or torque variation. When we talk about riveted gear train, a special compound gear train where the input and output shafts are coaxial. So, look at it, they are coaxial. Epicyclic or planetary gear. So, here you rotate this, all the other gears rotate, consisting of one or more outer gears. These are all called as outer gears. They are called as planetary gears, revolving around a central gear called the sun gear. It is also called as sun and planet gear train. In the center you rotate, all the other gears rotate, and you can try to get multiple outputs. Often used in automatic transmission. Speed and torque alterations. Gear trains modify the rotational speed and torque with respect to input and output. In a simple gear train, what we saw here, the gear ratio determines the relationship between the speed of input and output gear, impacting the torque inversely. Compound and riveted gear trains allows for more complex speeds and torque adjustments. Epicyclic train offers compact and efficient way to achieve large speed reduction or increase. Various applications. Simple gear train is used in clock and conveyor. Compound found in bicycle. So, this is compound in your gear cycle, where you have multiple gears, right, multiple teeths, they are all attached. Found in heavy machinery or bicycle. Riveted gear train utilized in automotive transmission. So, automotive transmission you can try to have. This here you can have. Epicyclic gear train, key component in automatic transmission and differential system. This is a differential system, DS. Gear ratio is one of the most important thing which we do. Number of teeth on the driven gear divided by the number of teeth on the driving gear gives you the gear ratio. When two gears are in mesh, the number of teeth on the gears determine their rotational speed. Gear ratio will be used for multiplying or dividing the speed. So, it can multiply in terms of increasing the speed or decreasing the speed. The gear ratio is defined as the ratio of the angular velocity of the driving gear to the angular velocity of the driven gear. So, angular velocity ratio is always written as omega. Let N1 be the number of teeth on driving gear G1 or gear 1, and N2 be the number of teeth of driven gear G2. Omega 1 and omega 2 be the angular velocities of gear 1 and gear 2 respectively. When the gears are meshed, so the linear velocity at the pitch circle of both the gears must be equal to omega 1 into R1 equal to omega 2 into R2. R1 and R2 are the pitch radii of gear 1 and gear 2 respectively. So, omega 1, omega 2. Relating the pitch radius and the number of teeth, the pitch radius R is proportional to the number of teeth on the gear. R1 by R2 equal to N1 by N2. Substituting it to the velocity equation R1 by R2. So, y omega 1 into R1 equal to omega 2 into R2. So, what I do is omega 1 into R1 by R2 equal to omega 2. So, this R1 by R2 is going to be omega 1 is going to be N1 by N2 into omega 2, or I can write it as N1 into N2 equal to omega 1 by omega 2 equal to N2 by N1. So, what did I get? I get the gear ratio. I get the gear ratio. So, gear ratio formula is derived accordingly. So, this is the formula. Final gear ratio expression G is expressed as omega 1 by omega 2 is equal to N2 by N1. Gear ratio G is defined as the ratio of the angular velocity of the driving gear to the angular velocity of the driven gear. So, it can be rewritten as number of teeth on driven gear divided by number of teeth on driving gear. The gear ratio is a very crucial component in determining the speed and torque output of the gear system. Higher the gear ratio implies reduction in speed but an increase in torque. If GR is high, then torque is high, speeds are low. This is very important. Because when the gear train ratio is high, torques are very high. I can lift heavy things, speed will be low. So, heavy things when I lift, the speed will be low. So, let us try to solve a simple numerical problem to understand the concept whatever we have seen till now. Okay. You have a pair of gears where the driving gear G1 has 20 teeth and the driven gear G2 has 60 teeth. Calculate the gear ratio. So, number of teeth on the driving gear 20, which is equal to N1. Number of teeth on the driven gear 60, which is N2. So, gear ratio formula is G equal to number of teeth on driven gear divided by number of teeth on driving gear, which is 60 by 20, which is 3. So, the gear ratio G is 3:1, which means the driven gear rotates once for every 3 rotations of driving gear. So, this also indicates that gear 2 rotates slower but with higher torque compared to gear 1. Okay. So, efficiency of the gear. Gear efficiency refers to the ratio of the output power delivered by the gear system to the input power provided to it, which is expressed generally in terms of percentage. It measures how efficiently gear transmits power from the driving gear to the driven gear. High efficiency means less energy loss. So, higher the percentage, loss will be lesser, which is crucial for the performance and the longevity of a mechanical system. Output by input, output power delivered by input power provided. Efficiency is vital in gear systems because it directly affects the energy consumption, heat generation, wear and the overall system's performance. This is very much used in automotive transmission, industrial machinery, robotics. Maintaining high gear efficiency is essential for optimal operations. So, the factors affecting the efficiency are going to be friction, lubrication, gear material, gear alignment and surface finish. Friction, when there are undulations on the surface and there is a matching undulation on the surface, there is going to be, this is moving, this is moving. So, there is going to be a huge friction. The primary source of power loss in gear, which can be minimized with proper design and material, is friction. Lubrication, in between these two, you can try to have a solid, liquid or a gas lubrication. Adequate lubrication reduces friction and wear, thus improving the efficiency. The gear material can be chosen depending upon the friction and the load of transmission. So, different coefficient of friction, thermal properties and impacting efficiency. So, you can try here metal, polymer. You can also try on a metal ceramic coating, or metal polymer coating. So, this is only to reduce the friction, but the other load will be taken by the metal part of it. Gear alignment. So, misalignment can increase the friction and thereby reducing the efficiency. So, there is a shaft, there is one more shaft. So, between these two shafts the alignment should be proper. So, that is why today we use something called as flexible coupling. Okay. This takes care of the gear alignment problem, misalignment problem. Surface finish has a direct influence on the friction. Smoother surface in contact area reduces the friction. Thereby, efficiency is nothing but output power by input power multiplied by 100. Let us try to solve another simple problem in the to understand the power and efficiency. The gear system has an input power of 1000 watts. So, P in is equal to 1000 watts and the P out is 850 watts. What is the efficiency? Efficiency is P out by P in into 100. So, this is 850 by 1000 into 100, which is 85%. So, the 85% is the efficiency of the system. The 15% whatever was the loss can be because of friction, because of misalignment, can be because of surface finish. All these things can lead to heat and wear. Okay. So, what are the forces which are generally involved in a gear? So, forces on a gear teeth. During the operation of a gear, forces are transmitted from one gear to the another through the contact of the teeth. These forces are crucial. So, you can see here there is Fx, along the x direction, there is Fr along the radial direction, there is Ft which is the torque. So, these forces are crucial because they determine how efficiently the gear transmits torque and rotation motion. The forces on the gear may be carefully analyzed to ensure that the gears can withstand the load without failing, without having excessive wear or deformation. So, the forces are very important to be calculated. So, when we talk about forces, there are two forces out, then the resultant of these two forces becomes the third force, tangential force. This is the force responsible for transmitting torque between the gears. It acts along a tangential direction of the pitch circle, tangential force. Radial force is the downward force, or it is a force from the radius. So, the radial force, the force acts perpendicular to the tangential force and is directed towards the center of the gear. It does not contribute to the torque transmission, but causes internal stresses and potential deflection. Bending of the gear happens. Radial force is also very important. So, for transmission it will be tangential, for radial it will be the internal stresses and the potential deflection. A combination of these two, R is nothing but Ft plus Fr, maybe root. So, resultant force is a combination of tangential force and radial force acting on a point of contact between the gear teeths. Understanding all these forces are very, very important. So, a small simple derivation we will try to do, because here we are more interested in power, and power that is always found from the torque. The torque in turn can be found from the ratio N1 by N2 or N2 by N1, whatever it is. Derivation. The force on a gear teeth can be derived from the relationship between torque and the pitch radius of the gear. The torque T is the rotational force applied on the gear. The pitch radius R is the radius at which the force is assumed to act, typically the radius of the pitch circle. We saw the radius of a pitch circle, radius R. So, the tangential force Ft is nothing but torque is equal to Ft into R, or if you want to find out the tangential force, it is going to be torque divided by radius. This will try to give me my tangential force. This equation clearly shows me that the tangential force on the gear train is directly proportional to the torque applied and inversely proportional to the pitch radius. If the pitch radius is large, then the tangential force is going to be low, where Ft is the tangential force on the gear train, T is the torque applied to the gear, and R is the pitch radius. Based on the understanding, we will try to solve a simple problem. The gear train has a torque which is 200 Newton meter. The pitch radius R is equal to 0.1. What is Ft? Ft is nothing but T by R, right? So, the torque is given, radius is given. So, from the formula, Ft equal to T by R, we get 200 Newton meter divided by R, which is 0.1, which is equal to 2000 Newton. So, the tangential force Ft is equal to 2000 Newton. So, the stresses, now we saw, after seeing the force per unit area is stress analysis in gears. There are two types of stress analysis generally we do to understand the ballpark figure. We try to do a bending stress, and then we also try to calculate the contact stress. Bending stress occurs in the gear teeth due to the tangential force applied at the pitch point, leading to a potential failure through the tooth break. So, bending stress occurs in the gear teeth due to the tangential force applied on the pitch, point, leading to the potential failure through a tooth breakage. Contact stress arises from the localized contact between the gear teeth during meshing. So, during meshing, which can lead to surface fatigue or pitting. Lewis equation is used to calculate the bending stress in gear teeth, providing a way to predict failure due to bending. So, what does this Lewis equation say? Consider a gear tooth subjected to a tangential force Ft at a pitch point. Pitch point is on the pitch circle a point. The tooth can be modeled as a cantilever beam, and the bending stress at the root of the tooth can be expressed as m divided by s. What is m? M is the bending moment at the tooth point. S is the sectional modulus of the tooth. So, with this we can try to figure out what is the bending stress in a gear. The bending moment at the tooth root is given as Ft into P by 2, where P is the circular pitch. So, sigma B will be Ft into P by 2 divided by the sectional modulus. The sectional modulus of a gear can be found out by S is equal to Fm into Y. What is Fm? Is the face width and a Lewis form factor Y. So, now if we put everything into the equation for finding out the bending stress, it is Ft into P by 2 divided by Fm into Y, which is nothing but Ft into P divided by twice of Fm into Y. So, to simplify, we multiply both sides by 2. So, we finally get sigma B is equal to Ft into P by Fm into Y. This is how we get the bending stress for a gear, where sigma B is the bending stress, P is the pitch, Y is the Lewis form factor, tangential for Ft and face width is Fm. So, where do we use this? Lewis equation is crucial in gear design to ensure that the gears can handle applied load without bending failure. It is used predominantly in selecting the proper material and the gear dimensions. Let us do a simple problem to understand the concept what we studied. A spur gear is subject to a tangential force Ft is equal to 500 newtons. The gear has a pitch of 20 millimeter, the distance between one teeth to the other teeth. The face width Fm is 10 millimeter. The Lewis factor Y is 0.3. Find out sigma B. Sigma B is nothing but Ft into P divided by Fm into Y, which is 500 into 20 divided by 10 into 0.3. So, which is 1000 by 0.3, which is 10,000 by 3 equal to 3333.34 megapascal. The bending stress for a gear is found out to be 3333.34 megapascal. This is bending stress on a tooth. To recap what all we have covered in this lecture, we have first seen what is gear, why is gear important, different types of gear, different types of teeth in a gear, then what is pitch circle, module, what are the difference between parallel, intersecting and non-intersecting shaft arrangements in a gear. How do you calculate the velocity ratio of a simple gear train? Derive the formula for gear train and explain its significance. Number of teeth on the driving and driven gear. How would you calculate the gear ratio? What is a efficient gear system? When do we use Lewis equation? while designing a gear. These are the reference book we have gone through. Thank you very much.